Good morning. Let's do some more confusing things. So today we're going to look at conditional statements. And we talked about this briefly on the last video. We talked about this statement here. If any real number, if x squared is greater than or equal to 1, then x is greater than or equal to 1. So this is the whole idea of conditional statements, is that we're talking about if something, then something else. And we're going to look at a bunch of examples, so hopefully this will make sense by the end. Okay, so let's start with the way you'll see it traditionally in a book is they'll say if P, and P stands for something, then Q. Nice and neat right here. So this is our conditional statement. So if P, then Q. And we can write this out with symbols. We can say if P arrow indicates then Q. Or we can do this with cool kid pictures. We make some ovals here. Kind of looks like a guy who's surprised. So what this is saying is if P, then Q. Alright? So this is all symbols. If we actually put in an example here. So let's say if a shape is a square, then it is a quadrilateral. And we see, is this statement true? So if your shape is a square, let's draw a square here, then is it also a quadrilateral? And you'd say yes, like it's got 4 sides. So what this little diagram here is saying is that if our first part, and we actually call this, let's name these here, the if part, this is our hypothesis. How do I spell that? E-S-I-S. Okay. Then it's a quadrilateral. This is our, maybe you can come up with this word, your hypothesis ends with a conclusion. And we check to see if our hypothesis is true, does it make our conclusion true? So this square, yes, is indeed a quadrilateral. So this statement is true. It's a true statement. Okay. If we try to flip this around, would it still work? If we said if a shape is a quadrilateral, then it's a square, and all that would be is we flip around our letters here. So quadrilateral is this big group of shapes like rectangles and trapezoids and parallelograms. Is it always going to fit into the smaller group of squares? No. So that would actually be false. Okay, so what we're looking for is a specific example, and then our conclusion is usually going to be something much more general. So our basic idea goes into a more general idea. Okay, if we look at another example here, let's erase this, and we can look at another one that's not true. So let's say if you are on YouTube.com, then what are we doing on YouTube? Of course we are watching the real Mr. Ellis. So what is our hypothesis here? Our hypothesis is that we're on YouTube. That's our if. That's our P. That's our very specific thing we're trying to prove. And then we say, is this generalization true about that? If we are on YouTube, are you watching me? Well, as of right now, probably yes, since you're here. But is this always going to be true? Is there other things you can do on YouTube besides watch me? Sadly, yes. So this statement is actually going to be considered false. And we can say, we can prove this is false, just like we did yesterday, by citing a counter example. So our counter example here is you could be watching, what are we watching? I don't know. The new One Direction video. Oh my gosh, so cute. Okay, so we have conditional statements, we check, we see if they are true or false. Okay, that's our basic example. And now we get into the note-taking part, so hopefully you brought your notebook and you can pause it here because I'm not going to stop and look at this for too long. But here is everything. So we started with what we just did. It's our conditional statement. If P, then Q, right? And then we have three others that go along with it. We have the converse, which is where we flip it around. So that's like we did our first example. We said, remember our first one, it says, if a square, then it's a quadrilateral. And we said that statement was true. The converse is if you flip the hypothesis conclusion around. So I would say, if something's a quadrilateral, then it's a square. And we said that was false. And now we get into some neat stuff here. Next one is the inverse. The inverse, which is like the negative, unhappy version of your conditional statement. That's saying, and this little symbol means not. So if not P, then not Q. So this is saying if a shape is not a square, then our shape is not a quadrilateral. And is that true? If a shape is not a square, then it's not a quadrilateral. So think about that for a second. Alright, so let's say, if you take a couple of examples, like if we said it's not a, let's pick any shape, it's not a square. So let's say a triangle. So is a triangle not a quadrilateral? We'd say yes, that's true. But that's not every example. Remember, we're looking for an example that doesn't work. So what if we say instead of a square we have a trapezoid? Trapezoid is not a square, but is that not a quadrilateral? And we'd say it is a quadrilateral, which means this statement is actually going to be false. False. Right? And then our contrapositive, getting extra fancy, is like the converse only flipped around and made more negative. So this is going to say, remember we started with if P then Q. We're going to switch the order around, so now it's Q then P, and then we're going to say if both of these are not true. Okay? So in this example, now we're looking at if a shape is not a quadrilateral, then it is not a square. And is that going to be true? If we pick a shape that's not a quadrilateral, is it true that it's not a square? And you'd say yes, because the only way you can have a square is it has to be a quadrilateral. So this statement, despite it being super negative and saying not and not, the truth value of the entire thing altogether is this is going to be true. True. Okay? So that leaves us with one last what's the word I want? Definition. Which we call a logical equivalence, which sounds really smart, and even smarter if I could spell it right. Equivalence. I think that's wrong. Hold on, I have have this written down somewhere. I don't have this written down somewhere. Hold on. Take a quick drink break. Equivalence. Oh no, that is right. Oh, okay, good for me. So, our 4 statements here, and you're going to see some patterns here, and that's going to be the conditional and the contrapositive will always have the same value. If the conditional is true, then the contrapositive is going to be true. If the contrapositive is true, then the conditional is true. Same goes for the opposite. If the conditional is false, that means that the contrapositive will be false. Right? And we're going to get way more into examples of these later. And then our converse and inverse, we notice a relationship here. If this is true, then the inverse is true as well. If the converse is false, then the inverse is going to be false. So these two are buddies, and these two are buddies. Right? So what this means, well, what we can say is some people might assume, well, if the converse is false, then the conditional has to be true. That's not always going to be the case. It could be that all 4 of these are true. It could be that all 4 of these are false. It all just depends on the situation. So you got to look at them one by one. Right? And we're going to look at examples of this later. But I don't want to stretch this out forever. So take a break. Have some breakfast. Okay. Like, comment, subscribe. Please.